Welcome, my dear learners. We are looking at the Theorem 3 of circle theorems. Now, the Theorem 3 is saying that angle which subtends in the same segments at the circumference of a circle are equal. And this is a diagram for this theorem. Now, what this theorem is saying that angle APQ is the same as angle AQB, which is the same as angle ARB, and all this angle is equal to what? X degrees, which means that if this angle is 20 degrees, angle AQB, which is this angle, is going to be what? 20 degrees, and angle ARB is also going to be what? 20 degrees. That is what this theorem is saying. Now let's try and see if we can prove this theorem, and then we try our hands on examples. So let's try to see if we can prove it. Now let's try to locate the center of this very circle. The center of this very circle. Now let's take it that the center of this circle is here with center O. So let's draw a line to join the center O from A. And then let's join B to the center O. So the center is center O. Now this proof is very simple because we are going to base on the second theorem to help us prove this very theorem 4. Now the theorem 2 is saying that angle at the center is twice the angle what? At the circumference, and this theorem is going to help us prove the theorem 4. Good. So looking at this, the angle with green pen. Now from O to P, now we can see that this very figure resembles the theorem 2, which says that angle at the center is twice the angle at the circumference. I hope you can see it. Make sure you have a geometrical eye to see this. It's very simple. So we can say that our angle here, which is angle AOB, is equal to 2x. So this angle is 2x. So applying the theorem 2, which says that angle at the center is twice the angle at the circumference, definitely this angle is going to be what? X degrees. Very good. Now from the same point, we can see that we are getting the same diagram as the theorem 2, and we are going to apply the theorem 2, which says that angle at the center is twice the angle at the circumference. So looking at the same diagram with the red ink, you can see that we are having a theorem 2 diagram inside. So if this angle is 2x, this angle is going to be what? X. Now from the same point at the center, we can see that this very diagram here, AOBR, resemble the diagram of theorem 2, which says that angle at the center is twice the angle at the circumference. So this angle is X. We are done with it. So we can say that angle X is equal to angle X, which is red, is equal to angle X. So we are done. Let's try to see if we can apply this theorem in solving examples. So we have the example here. If O is the center of the circle, find X and then Y and then Z. X, Y, and Z. So we have to find this angle, and then this angle. So starting with angle X. Now from theorem 2, which says that angle at the center is twice the angle at the circumference. Therefore, we can say that angle ADB, which is this very angle, which is equal to x, is equal to 100 divided by 2, and that is giving us what? 50 degrees. So you can say that x is equal to 50 degrees. Now that we are done with x, we can move on to z. Now with z, from theorem 4, we can get z from theorem 4, which says that angles which subtends in the same segment at the circumference of a circle are equal. In other words, angles in the same segment are equal. So it means that this angle is equal to what? This angle. So we can say that from theorem 4, angle ADB is equal to angle ACB, which is equal to what? 50 degrees. So therefore, finally our z is equal to 50 degrees. Very, very simple. Now we are left with y. Now we can get y from theorem 3, which says that angles in a cycle, the opposite angles of a cycle quadrilateral sum up to what? 180 degrees. Therefore, this angle plus this angle is equal to what? 180 degrees. We have a quadrilateral ADB, and it is inscribed in a circle. So we can apply that very theorem. So from theorem 3, opposite angles in a cycle quadrilateral are supplementary. So you can say that angle ADB, this angle plus angle AEB is equal to what? 180 degrees. But we know that angle ADB, which is here, is 50 degrees. So we have 50 degrees plus angle AEB is equal to 180 degrees. Grouping like terms, we have AEB, which is equal to y, is equal to 180 minus what? 50 degrees. So you can say that angle AEB, which is the same as z, which is the same as z, is equal to 130 degrees. Very, very simple. We are done for the day. Thanks for watching.